Again, welcome to our next session, this time on something that has not been around that long as DECT. It's about NFC, near-field communication, something that is quite young, and we can have a look on it at a very early stage. So welcome to our speaker, Colin Mulliner, on NFC. Thank you.
Hello. So tonight I'm going to talk a little bit about NFC mobile phones and the security issues of the phones and the services you can actually use with those phones. So the talk is more or less a first overview of NFC phones and the security. I will present some tools I developed. I will show you some proof of concept attacks and show you a small survey of NFC services that are actually in the field, which are not public field tests, so services you can actually use and abuse. A little bit about myself. I'm a professional researcher now. I mostly work with mobile phones, smartphones, and Wi-Fi, wireless stuff. Yeah. If you want to contact me, email address is there. So why would you be interested in NFC? Okay, NFC of course is like very new, so it's always nice to play with something new. Some mobile phone operators and public transportation companies, they actually try to push the technology so they can make their life easier and as I said before, mobile phones are really my thing, and so every new thing that happens to mobile phones, I normally take a look at it. NFC is, as you will see later, more or less RFID, and RFID is very interesting for many people, so another reason to look at it. And of course, the overall plan for the NFC community or the companies behind the NFC standard, they really want to see the NFC going into every mobile phone, and so I will first give you a short introduction of NFC, show the data formats, then I will show you what I did to analyze NFC phones and services. I will show you the services that are out there at the moment, and then I will give you some notes from my testing lab. I found some other interesting tidbits about NFC phones and what they do with, like, for example, the MyFair cards they read or write to. And then I will have some conclusions at the end. So near-field communication is proximity coupling technology like RFID. It's really based on the same ISO standard as all the MyFair stuff, the ISO 1443 standard. And the difference really between NFC and the normal just RFID cards is that you have 3 modes of operation. So a phone, like example this phone, it's really a RFID reader and writer. It can emulate cards, or better, it actually has just a built-in card which you can talk to from the application CPU, and then you have the third mode, which is the actual NFC mode, where you can just use NFC as a bidirectional channel to talk between 2 NFC devices, for example 2 phones or a phone and some mounted device next to a door, for example. But for now I will only talk about the reader-writer modes, because these are actually the modes that are mostly used in current NFC phones and in the services that are deployed. Also, these are the modes where you where you have the most fun outside of the NFC area. So if you're just an RFID hacker, these are the modes you actually want to play with in the field. So small technology, I guess the guys earlier from the RFID talk already showed you all that, because MIFARE is in the exact same technology. So 1356 megahertz operating frequency. You have a reading range about 4 centimeters. They actually say up to 10, but I actually never managed to read like over more than 3 or 4 centimeters. Yeah, data transfer rates are pretty low. Yeah, the supported cards are all the ISO 14443A and B. These basically are the NXP stuff, MIFARE Ultralight Classic, 1 and 4K, the Desfire stuff, the Sony Felica, which is actually only used or mainly used in Japan. I don't know the other two card types. I never saw them. I just copied that from the standard. So if you see it somewhere, then you know it's probably some NFC-based stuff. So the general stuff, the general problem or security problem with the NFC stuff is that you don't have any link level security. So if you just are able to sniff the stuff, you can just sniff it and you have the data. You can basically do man in the middle. If you can do that, you can actually modify, corrupt, or just insert the traffic on the air. It has been shown, I think, by 2 or 3 researchers in the UK. And the other things, if you deal with passive stuff, so with reader-writer mode stuff, you mostly have passive tags. So you can modify tags you find in the field, replace them, destroy them, whatever. It sounds easy, but sometimes it's a little bit harder. But yeah, I will show you some nice things there. So just as a small introduction about the concept that the manufacturers and the NFC forum have. So the basic thing is you place tags for now at your point of service where you want to sell like a ticket or some snacks or get some information, visit some website, and then you just go there with your phone, hold it up to the tag. You don't need to touch it. Even they use the term touch to describe the user scenario, but you basically go there and hold your phone up to the tag, read the data, or the phone then hopefully reads the data and performs some action. So it's more, it's really to make it easy for the people to use it, because everybody can just take their device and hold it up to some other thing, and that's no big learning thing. So right now, what you can do with the standard phones like these is just So I was just asked to ask the people in the back to be quiet, please, or if you're not interested, you can go outside and talk there. Thanks. With the current phones, you have some basic operations which are just supported out of the box. So you can just have like a URL stored in a tag, and you hold up your phone, and the phone just launches the web browser, loads the site, or it asks you to initiate a voice call. So you just get a small pop-up and say, yeah, do you want to call this number? You can send SMSs, can read V-cards or calendar entries. On the new phones, you can even like program an alarm for your alarm clock on the phone, change your phone ringing profiles, so silent or general, whatever. You can launch custom applications. So if an application is stored on the phone, it can say, if you see this data, please launch me and give the data to me. Or whatever other idea you come up with. So to do the things I just told you could do, there is the NFC data exchange format, short NDEF. It's basically just a storage container format where you can store data onto arbitrary RFID tags. And the NFC stuff or the NDEF stuff defines a few data types like the URI, which could include, for example, a URL. Then you just have a text field, a text record, which is just some text and a language identifier, and the smart poster, which is a special form, which I will, special data format, which I will talk about in a second. All the standards, the stuff is standardized and available for free on the NFC Forum website. So if you want to play with it, you can just download the spec. It's not very big, and implement it. Also, you don't need to implement it because I made a nice open source implementation, which I will also talk about later. So. So the smart poster is a specific, format, a specific type of URL where you actually have a URL and a text record. So you can actually, instead of just displaying, for example, HTTP ://ccc.de, you can also display the text like this is the website of the Chaos Computer Club. You also have additional stuff like you can say if the phone reads a tag, we recommend that the phone immediately opens the website or just saves it for later or anything like that. You can also say, okay, this URL points to like an object of, I don't know, 5K or 6K. So maybe if you pointed to an image, so the phone knows, okay, if the size is like 500 megabytes, the phone may say, I won't open that URL because I don't have this amount of storage. And the smart poster is really one of the key cases for NFC. At least they say that because it like moves the internet like closer to your mobile phone, where you just like instead of punching in URLs in your phone by hand with like this nice 9-digit or 12 keypad, you just go to the tag and read it, and then you visit the internet or do other stuff. So that's why I took a closer look at the the smart poster stuff. Yeah. So to the mobile phones. When I started, there was only this particular phone from Nokia available. It's a very simple Series 40 mobile phone with just an NFC chip added. Then I just shortly, like in November, I got the newest phone, which is a little bit nicer. It has also UMTS. But so most of the stuff I'm going to talk about is about this phone. All other companies, or like not all phone manufacturers, but the big ones like Samsung, Motorola, and I don't know, I think Sagem, they all are building NFC-enabled phones. Also, as far as I know, only the Nokia stuff is available on the free market. So yeah, that's why I got one of those. Yeah. So yeah. The phones are really basic Series 40 phones. They have Bluetooth, support all the standard NFC NDEF file formats. Nokia added some nice extensions to their phones, especially for the Bluetooth stuff, and they also added some extensions to the JSR, to the Java API around NFC, so we can do really nice things with a Nokia NFC phone. So yeah, what I said before. You basically have the NFC chip in the phone, And as long as, of course, the NFC subsystem is switched on, the phone constantly scans for NFC or RFID chips. If it finds a chip or a tag, it will try to read it. If the chip actually contains an NDEF formatted data, it will read the data, check the MIME type of the data. So NDEF also has a MIME type, and some specific other NDEF types. So it will basically just read the data, check for the type. Then it will launch the application that is associated with the type and just passes over the data. Of course, if you have your own application running or any application that is NFC aware running, the application will get the data, and then you can, or actually the application will only see there is a chip available, and then the application can just go and read the chip or write to the chip, depending, of course, if it knows the keys to the chip, if the chip is a chip where you actually have access control. Yeah, so the push registry, this is the part where you can actually register these MIME types, is a lot of fun because you can actually register more than you should be able to. So I think almost at the end of the talk I will show a small gadgety thing I wrote around the push registry. Then sadly you cannot register all types, so it would be nice to just register the smart poster type. So instead of the stupid Nokia pre-installed handler for the smart poster, I could just launch my own application. But for, of course, security reasons, they don't allow registration for particular types. So sadly, but yeah. So if you look at the security of the NFC phones, you will quickly see, or especially at the moment, that the NFC phones are not smartphones. So these are really simple feature phones, as they are normally called. We don't have native applications. You mostly have no Wi-Fi, very limited UI, very limited storage, very limited processing power, and of course, especially, no native applications, no native development. So the tags are more or less either denial of service stuff or social engineering stuff, where you show funky data to the user and hope to trick the user into doing stupid stuff or stuff that hurts them. So if you find bugs, of course you can easily trick users into doing stupid stuff. So we're really not talking about buffer overflows and code injection yet. So my talk will only go about social engineering stuff, and hopefully in the future we will see smartphones with NFC, so we can do some real bad things. Yeah. So okay, of course we don't only have the mobile phone, we also have the service application, the services or applications. So you not only try to attack the mobile phone and the system parts or the applications on the mobile phone, but you also have the stuff like the tags that are actually mounted everywhere. Of course, back-end infrastructure, if you can somehow reach it. And the interesting part, most of the systems seem or look to be designed to really protect the service provider and not the customer. So maybe you don't manage to attack the services, but maybe you can abuse the services to attack the customers of the service. So another nice thing there. So I don't know, did most of the people attend the RFID talk? So most of the stuff, I just have one short slide on the MIFARE Classic stuff because I thought there are so many RFID talks here that I don't need it. So the thing is, the MIFARE Classic tags are really the tags that are used everywhere in the NFC area. The only place where I haven't seen it is the Deutsche Bahn touch and travel stuff here in Berlin. They use some kind of smart card where actually just send commands to and talk to the card instead of just reading data off the tag. For the MIFARE stuff, it's interesting because because you have two text types which store different amount of data, which if you do some fuzzing is very interesting because the MIFARE 1K is most widely used. So if you do fuzzing, you might want to use the MIFARE 4K to put a little more data on it because maybe some stuff is made to work with 1K stuff, with 1K data, but not with 4. Yeah, and the other interesting thing is, of course, MIFARE uses this read-write keys, so you can actually protect the data that is stored in it, so you can configure a tag to be read-only, which will also be interesting later. So if you look into NFC security, you first want to, I first started to actually think about what tools do I need. And the first thing, of course, I want to read and write the tags I find in the field. And I also want to write data to tags so I can give the tags to my phone and let my phone try to read them. So what I actually did is wrote two applications, one that just runs on my PC and uses a USB reader, and one that runs on the phone. And then, of course, you need libraries, so you can actually parse the NDEF format and, of course, create data in the NDEF format. And the library should also be very flexible because you want to do fuzzing. Then later on, when I started looking more into the actual services in the field, I thought, okay, we actually want to see if the security settings on the tags that are deployed, because, hey, maybe somebody forgot to set the tags in the field to read only. So you don't want to, of course, carry your laptop around and hold it up to tags because it might look suspicious. So most of the tools actually run directly on the phone. So the first tool was, of course, the NFC, the tag reader, which is based on the librfid stuff from the Open PCD project. So it's basically just a wrapper around the MIFARE tool, which just writes the data in the NDEF format to the tags using any USB writer that is supported with librfid. The tool can just like read-write tags, dump the whole tag, wipe the tag, and of course NDEF format the tag, because the tags need to have a special keys. So if an NDEF formatted tag on a MIFARE chip needs to have special keys set for reading and writing, so they're not, they don't use a standard FFFF key, which is normally set to all sectors on a MIFARE card. If you buy it, they have a special key, which is of course public documented, because everybody needs to be able to read the data of that. The second toolkit is what I said before, is the toolkit that actually runs on the Nokia phones. The tags the tools not only read and write the data, you can also, it has a Bluetooth interface, so you can actually talk to your laptop or with your PDA to the phone to actually control the reader and the writer of the phone from an external device. In the default mode, the application will just allow you to go up to a tag, read it, store the information, read another tag, go home, and just dump off all the data. You can also upload a tag to the phone, and then you can just go with the uploaded tag data and just write it to any writable RFID tag. These are the tool names are there. They're on the website in complete source under the GPL license. So the second part was the NDEF library, because of course the tools are the actual reading tools are just simple reading tools that just read and or write raw data to the tags. The library basically just implements the complete NDEF standard, so or you have the records and the messages. So a message is just a bunch of records. We have the high-level data structures like the text URI record and the smart poster stuff. Then I also implemented the Nokia custom stuff. They have a Bluetooth tag where you can actually initiate some Bluetooth action from reading a tag, the change profile stuff, and access to the phone gallery. And since the RMV that I will talk about later is a metropolitan area transport in the Rhine-Main area, they also have tags deployed in a special format. So I dumped a few tags and just wrote a parser for that. So if you also dump tags, you can easily see what's inside. And of course, the whole library is fuzzing ready, so you can actually manipulate every interesting part, like length fields that don't match the actual length of the content. All the stuff is written in Python, so it's easily extendable. Yeah, the library just like dumps either stuff in hex or binary and reads data in hex or binary. So wherever you get data, NDEF data from, you can stuff it somehow in the library, and you will be able to hopefully get the output. Yeah, it doesn't depend on anything else than just the core Python stuff. So you don't need any additional libraries. Of course, if you want to actually talk to the phone reading tool, the tool that's running on the phone, you just need the Bluetooth Python stuff, but that's available for, I think, at least Linux and Windows. Recently, I also included a GUI tool, so you can just have a nice GUI and just put some data in and write tag types. I think the URI smart poster and just plain MIME type tag. So you can just load any file that, of course, needs to fit on the NFC tag, and just set like, okay, MIME type image JPEG, and just write it out. And so you can test if and what types your phone can actually read very simply without needing to understand anything. You just need to run the application on your PC, install the application on your phone, and go and play. The last tool is the MyFirst Sector trailer testing tool. This is a tag security testing tool where you can just analyze the read-write state of MIFARE tags. For now, since, as I said, the MIFARE is the most common stuff around. Yeah, so it just tells you which sector is readable and writable by which key. Of course, it doesn't show you the key. And then I tried to implement a wordless or cracking thing to just see if somebody was very stupid for selecting keys for the tags. Yeah, it's very slow, only 10 keys per second. It's just to see if people were stupid. I don't expect that this tool could break anything. It's a 48-bit key, so yeah, you don't want to wait that long at the bus stop anyway. This tool is, of course, also available in source. And yeah, I saw some people running or also using it for other stuff, because it's easier to just hold your phone against the tag and see the read-write state instead of like powering up your laptop and checking with your other fancy tool. But so this is nice to see. So now that you have all the nice tools, you actually can start the analysis. And of course, the first part is you want to know what parts of the standard are supported, because yeah, it doesn't make sense to like do extensive tests on stuff that the phone just completely ignores. So what I see that the Nokia phone basically just supports all the standardized NDEF stuff. It just ignores the action part of the smart poster, so you cannot actually tell the phone to immediately open URL that is stored in the smart poster, which is really sad because that would be one of the nicest attacks anyway. Then, yeah. If you know what is supported, you start checking for implementation issues. And just, you do, of course, just not are purely interested in the actual feature or the actual parts that do the parsing of the NFC stuff, but you're also interested in the security or functionalities of the applications that actually are controlled by the NDEF or NFC stack on the phone. So because just reading a URL or a phone number from a tag is one thing, but if you can do funky stuff with the actual data that is passed to the other application, yeah, that's where it gets more interesting because, yeah, as I said before, buffer overflows will just like crash it and not help you like do code injection for now. So looking at stuff that is controlled by the NFC stack is really interesting. So the first thing I noticed was, yeah, you could easily do URL or URI spoofing because the way that a phone displays the contents of a smart poster really mixes the informational part, so the text record, which is just descriptive text, and the URL. And so the user cannot really see which part of the text that is displayed to him is the actual URL and which part is the descriptive text. So if you craft nicely craft smart posters, you can really trick the user into doing stupid stuff. And the vulnerable components, that is really interesting because it's like the three big thing you have on these phones is the web browser, the phone dialer, and the SMS application. So what you basically do is you show a really harmless or maybe interesting URL to the user, which you're sure the user wants to open, and then you just, the actual URL of course points to your bad, yeah, website or phone number thing, as you will see in a minute. And what the trick is very simple, and so I was really amazed that it actually works. You just pad up the text so that the display is too small to actually show the complete information. So it will only show the text, and if the text also has HTTP blah 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 in it, the user will believe, oh, that's the actual URL I'm going to open. So what you can do, the actual URL you put whatever, so this is just the URL to my blog, and put in the title Nokia.com, pad it up a little, add address. So the first screenshot actually shows what the phone will show you if you just go and read an URL tag. If the tag would not be a smart poster and just a plain URL, it would look exactly the same. Also, if you just have a normal smart poster which doesn't have a title, it will exactly look the same as the left screenshot. So if you used to use the stuff, you will think, oh, okay, that's just a URL. I don't care. I just open it. And even if you then say, okay, show me the details, you will see the screen in the middle where you see, okay, title, address, everything is okay. Of course, there's a scroll bar on the right side, but hey, the display is so small, and if you already found what you're looking for, you might not go and look any further. So you even like survive a brief inspection by some curious users. And the third picture is, yeah, if you actually open the URL, you will actually see, okay, that's not Nokia.com, that's Malina.org what is loaded. Yeah, and then you can do a lot of things with that, as I will also show later. Yeah, one of the things will be a nice man-in-the-middle proxy by using just a CGI thing. So instead of having like a SOX proxy, you can also do with a CGI script which loads the web page you actually want to go to and pushes this down to the user. And the nice thing why this is working, because all these small fonts actually don't display the current URL. You only see part of the host name, and so you can put just replace a tag that's somewhere in the field, put the fake URL in that, put your own URL with a proxy in between, and if this tag points to some site where you may log in or something, you get all the credentials. Because, of course, the browsers also don't show if you're using HTTPS or SSL. They actually only show you some warning if the certificate is not there, so you just downgrade to HTTP only and no warning, and everything looks as usual. Very, very low tech, but it works just fine. So now it gets more interesting, because loading a website doesn't not cost you that much money, maybe a few cents for GPRS data. But phone numbers will immediately cost you money, and if you dial a really expensive number, it can go up to maybe 20, 30 euros for just one call. So if you can, fake the call screen, you are in the business for making some money. So basically it's the same thing. It's a smart poster again. The actual URI is the 900 number. The other number is, okay, maybe some tourist information thing. I think I saw that in some demo slides from the NFC thing. So you go to some other country and just want to call the tourist information. You can just hold your phone up against the thing and then just call the number. Of course, on the left side again, you see, tourist information, 800, so for free. May just call it. And again, you can just manipulate the title enough so that it looks totally legitimate, and that the user has to do some scrolling. Normally he will not do that, because if he sees what he's looking for, then he stops looking for it. So again, same simple attack, but now it starts costing some money. The same works with SMS too. So the same again. You can also define the SMS body. So in this, the right side is actually the Yamba or the Yamster for the Americans phone numbers. So you can activate your nice subscription to a new ringtone each week for now 1 trillion euros a day. Of course the SMS case is not too easy to attack, because you don't have this, there's no the second screen is actually shown on the right, so there's no just view screen, so you have an edit screen, and so you couldn't manipulate the brief inspection thing. But as you will see later in the survey, there's still a nice attack you can perform, because if you actually always see the same text on the left side, you might not look again inside to see what is really there, because you already saw it 100 times. So the really fun part is when I looked again into the spec, because the spec actually exactly tells the implementers to make sure that you cannot mix the text and the URI of a smart poster, because you can do bad things with it. That's just a funny detail, because if I would have read the specs in more detail in the beginning, I could just, I would have tried this at first. So, always, completely read the specs at the beginning. So I played a little bit more with the URL spoofing stuff. Since you can also store URLs on non-smart posters, and if you just have a URI tag without the description, you cannot do the faking where you have tags, the description text which looks like an URL. So you just use the thing, I don't know, maybe from 5 or 10 years ago, what spammers used to do, or fishers actually, where you just use the nice thing with the at. So the beginning of the URL is actually not the host name, it's just the username. Yeah, the phone produces a nice broken HTTP request, but you can just run your own small HTTP redirector, which just reads everything and just issues redirection answers. So you can easily also use that. Another issue, what I showed earlier, is like the partial hostname thing. So if you register in domains that, look very similar to the ones you want to impersonate, you can easily do that because the phone will not show the complete host name to the user. So this is shown here. So the username part on in the first picture on the left side, you see that the URL looks correct, but somehow has small problems. So you cannot have slashes, forward slashes in the username, but just backslashes. And you cannot have question marks, so you just replace this with an ampersand. And for the average user, this will just look sufficient. So in the URL will be just, again, you have put a bunch of new lines there, so the rest of the URL is not shown in the initial screen, and also in the detail view you have to scroll. And then in just using your using port 80, you just put some other port so you can talk to the redirector proxy, and everything will work just fine. So there's the last part with the actual host name, and when you load the site, you only see wap minus rmvde. The rmv again is the public transport thing. I actually didn't do anything with their service, but since this was my starting point for the whole stuff, I always used the RMV domain as examples to show. Just nice and small, and so since all these issues are more or less implementation issues, I had a nice chat with the guys from Nokia. They were very nice and told me, they're going to fix everything, and it looked good. So they actually fixed the stuff, and now they brought out this new phone where most of the bugs actually don't work anymore, but only most, since you just have a new way for the plain URL spoofing. Since if you have very long URLs, they just replace the end that doesn't fit on the screen with 3 dots. And so you just put 3 dots at the part where you where the screen where you can just test how long you can make the URL, and then just put 3 dots, and again use the good old add trick, and again you have very simple form of URL spoofing. Browser doesn't display the URL or host name, so you don't even have to care about registering funny looking domain names, because the user will never ever see the host name. So it's the same thing again, just a new phone. Very very simple. So now back to the Java API for the NFC stuff. In the beginning, I told you that that you could just register certain MIME types or NDEF types for your application. So if the phone reads this type or a tag that contains this type of data, your application will be launched. The interesting part is you can just register for the general URI type, which is really bad because there are many use cases where you just have an URI type as a major type and then have another type as a subtype. And so other applications maybe say, okay, I want to register for, I don't know, HTTP or whatever URIs. I don't know if that's possible, but you can have like some specific subtypes of URI you can register for. But they didn't think about that, and yeah, you shouldn't be able to register for the general URI type, because if you register for it, of course you will get all read events for the generic type. So if you could write a small worm, or actually I wrote a small proof of concept worm that hooks into the reading event for URI tags. So every time your simple URI tag is read, the application starts, reads the tag data or the URL, yeah, then it writes back a smart poster which points to a copy of itself, like just to the jar file, the URL to the jar file of the worm binary on the internet, and the title, and writes a title that looks like the original URI. So if you read the tag again, it just looks the same. And this all works because the one phone I tested it with, it just if you open a URL that points to a jar file, it will just download and install the tag, the application, without any questioning the user if he really wants to install it. It will just ask, yeah, do you want to run what you just installed? So maybe you say yes, and then you have you're infected with this small worm. So yeah, I did the first version of this talk at USEC West. So yeah, you get the sample from that. So on the left side, you will see, okay, you read a tag that that shows, okay, HTTP, www, whatever. And so do you want to open it? Since you just read a tag, you might, yeah, want to say yes. And instead of opening the website, you will just see, okay, yeah, yeah, do you want, yeah, oh, yeah, open the downloaded application. If you say yes because you're curious, yeah, you will just run the worm, which will just register and immediately quit. Yeah. Yeah. So, and if you actually then read a tag later, the application, the worm starts and say, okay, the tag read failed. Please touch it again. And yeah, you see the actually application looks like the phone interface itself. So you might think, okay, this is actually an error message from the phone. So, and if in the moment you touch it again, the worm will write itself out. Yeah. In the second step, it will just like go and start the web browser, or ask you to start the web browser for the original URL. Of course, if you're really used to using these phones, you might see, okay, this is not how it normally looks like. It is, and of course, it's just a really simple proof of concept thing to just show that if you can register wildcard MIME types for the NFC stuff, then stupid things could happen. Yeah, so on the server side, basically there is not much stuff. It just like checks if you have a cookie. Since if you have a cookie, you won't get the worm binary again. It will just issue a redirect. So if you're already infected and read another tag that contains the worm, you will never actually see that. You will just see the normal website and everything just works fine. Again, yeah, a really simple proof of concept here. So after playing with the basic NDEF stuff where you actually manipulate the content to trick the user, I thought, okay, this was really fun, so maybe we can get some nice crashes and or other stuff. So I started to do some fuzzing. Yeah, basically just my NDEF library in Python, the writer tool, normal USB writing, USB RFID writer, and a bunch of tags. Yeah, I tested my phones, and yeah, they're some really nice things, because if you set the size of the payload to all Fs, your phone apparently tries to pre-allocate some memory to store the complete data, and this greatly fails and the phone reboots. So so it's quite fun. The same works for very long telephone numbers. So if you have a telephone number that is 124 characters and a smart poster or normal URI tag or SMS URL, it's the same thing. Just simply reboots. Probably the telephone stuff is probably an off by one error, because if you do numbers that are bigger, you just get an error screen, and if you use fewer numbers, then you will just get the number displayed. So some missing test case for the developers. The really bad thing for fuzzing so far was it's really time consuming, because you have a card, put it on the writer, take the card, hold it to the phone, see if the phone does something stupid. So it's really not optimized so far. Now there are some nice card emulators which I'm probably going to buy, and so I can do a little bit more testing, because right now testing is very boring, like watching TV and doing some automated thing with your hand and watching your phone too. So the interesting thing about the crash is actually the phone does not completely reboot, it's just the GUI system. But if you get to crash the phone 4 times in a row, it will completely switch off, and you have to press the power button again. As I said earlier, unfortunately, there's no real documentation, or nobody ever played with code injection for the Symbian S40 series, besides some stuff with a Java engine. So, but it's not as mainstream as Linux or Windows. So this is not, so if you find buffer overflows, it will be not that interesting. But of course, if we go to smartphones, hopefully maybe next year or in 2 years, where you have NFC and smartphones, all the buffer overflow stuff and code injection stuff will be way more interesting, because we might think about going to some information booth and instead of visiting a website, installing a virus by just touching a tag. It would be really nice, because you couldn't trace that back very easily, because there was no network connection, nothing. It's just you go somewhere and get owned. But this is future stuff. So almost at in the last part. So now we have a bunch of vulnerabilities on the phone. So denial of service attacks and some spoofing stuff. So I thought, okay, what can we actually do with this stuff? Because I could just go up to somebody and say, hey, do you have an NFC phone, and read this tag? But this would be stupid. So I looked around and saw, okay, in Frankfurt, where I live, we have some NFC stuff, and the city of Vienna in Austria, they actually have at least 4 services in the city which use really simple NFC stuff, where you just have RFID tags everywhere. So I did a small field trip to Vienna. And the first thing is that most of these additional servers, they don't actually require you to install anything on your phone. So it just uses the default features like displaying URLs, calling phone numbers, sending SMS. So really simple. So I just took my phone with my testing applications. I didn't carry a laptop, so I could just walk around in the city, or just if you go out to Frankfurt at night to do stuff, you just go to the train station and read some tags. And of course, you can just, at home I just like dumped the stuff off and looked at it on the laptop, but just being able to analyze it with just the phone makes it really fun, and you can do a lot of data collection because, yeah, the phone is small. So the first thing, and I think the second most interesting part was the Wiener Linien. It's basically just the inner city public transport. So they have this RFID tag stick on every ticket vending machine. So you can either go there and just put money in the ticket vending machine and get your ticket, or you just hold up your phone. Then you will get this nice message with, do you want to buy a ticket? €1.70. Yeah, and if you say yes, it will send an SMS, and you will get back a ticket via SMS. Of course, the billing is done simply by deducting the amount from either your phone bill at the end of the month, or if you have not PayPal, but some other. Some other payment service, it deducts the money from there. First thing, of course, if the tags are not read-only, I could just like hijack the tags and put my own stuff there, but yeah, at least they made everything read-only. Of course, you could just put a sticky tag on that and just put another a message that looks the same if somebody with his phone goes up to the reader and it says, okay, yeah, I want to buy a ticket. The message looks the same as always because he already used it 50 times, so why bother to check the content? We'll just send it. But if of course the SMS, the phone number for the SMS points to some expensive number, you get to rip off some people. Of course, they will say, oh, I didn't get a ticket back, but maybe it doesn't. They don't like really realize because they sent the SMS and just put their phone into their pocket. Maybe they will only realize if they get asked to show the ticket in the train. And the other thing is maybe you don't even need to like do the funky spoofing stuff. You just put another phone number there, but because the message just looks the same, they will just say, oh yeah, whatever. So if you This is a really bad service for the customer because it's very easy to rip him off with that. Because if you put the stickers you can buy which are RFID tag are very, very small, like about something between a €1 and a €2 coin, the size of that, so you can just stick them there, and nobody will, or no technical skilled people will think that some piece of paper will have anything to do with a tag behind that, so they cannot associate that to an attack or something bad. Yeah, so yeah, maybe you just bought a €3 ringtone for your ticket on your last trip to Vienna, but yeah, I guess nobody here has an NFC phone. I never found anybody who was not playing with the NFC stuff directly having a phone. So the best service actually in the city was the vending machines, where you can actually buy a snack also by sending an SMS message. You see it? It already shows the subtitle of the site, the snack attack. So it's basically the same functionality as with buying the train ticket. You go to the machine, hold your phone against the machine, then you get to ask again, or do you want to buy a snack? Then press send now, and after that you can just like select the snack you want to buy, and then just pull it out. What will happen is that your phone number matches your user account to, of course, the payment system, either again your phone bill or this other SMS payment system. So you will just know, okay, this user just authorized the buying of an item from this machine. And yeah, so what we can actually do, we can go and copy the tag from one machine, make 10 or 20 of them, go around in the city and put it on other machines, and then wait on this one machine where you copy the tag from. And if at the moment the machine will light up and say, hey, you can now pull out your snack, you just pull out your snack and go and run. So, and it's really nice because you shouldn't leave any traces. Of course, all the places where the machines, where I saw the machines are subway stations, so they have like heavy video surveillance. So yeah, maybe just wear glasses and a hat or something. Of course, I haven't tried it. It's just like theory. Of course. Yeah, so this is really a nice thing, because in the other case where you have to like register a 900 number or something, somebody will be able to trace you down. So, but if you just go around and put stickers on machines, maybe even on machines that were not NFC enabled before, so you can just enable your own machines. Yeah, very cheap. I will later show you like the tag prices, and that's really affordable if you just buy small amounts. Yeah, so the last service in Vienna I looked at is another ticket buying, e-ticketing for the trains, not the subway anymore. Unfortunately, I could not get to see the website. Probably say detect that you're not on an Austrian carrier. So I just saw the URL. Because this thing goes actually to a website where you log in and buy your ticket with your account. So what you could do is just put another tag on there, which has the nice man in the middle proxy in between, so you can steal some credentials, or maybe just push some malware down there. Yeah, so that's basically the only thing, not too interesting. So the next, actually the first part I actually analyzed was the RMV, the Rhein-Main-Verkehrsverbund tickets in Frankfurt. This is a more advanced thing, because you actually have to install an application on your phone to actually use it. The sad thing about it is actually that NFC is not really necessary. NFC just makes it easier for you to use the service, so you don't have to put in the number of, or the name of the train station where you currently are. But it has some other very interesting parts. So first, they really don't use the smart poster stuff. They have their own custom type, rmv.de:/HST, and then they have a station ID and a station name. So you need the custom application to read that. Or actually, you just hold your phone up to the tag, and then it will launch the application, will show you, hey, you're currently at the main station in Frankfurt. Now, please enter your destination, and then you can buy a ticket on your phone. They have another URI record, so if you don't have the application installed, you just have an URL which points to the website for the schedule for this current station. So you could just put another tag there, which maybe shows goatsy to the people who want to see the timetable. So this is what a tag of a contact of the RMV actually looks like. I actually have many samples and dumps on my website, so if you want to see something. The interesting part also is to actually sign the data on the tag. they actually sign the data on the tags, so you cannot produce your like own tags for like stations that don't exist or something. But you could go and just copy, again, just make a copy of like one station in Frankfurt and put it on all other stations. Yeah, it wouldn't be it wouldn't like do anything bad, and it's really funny because like they sign it, but the signing is really stupid because it only signs the data on the tag. So if you just copy the complete data, including the signature, you can still put it on any other tag, and the software on the phone will just say, yeah, okay, will just accept it as a valid tag. So you can like. I actually tried to like confuse the application on my phone. I took 10 stations, put it on 10 different tags, and just touched the tag very fast in a row to see if they have like some stupid detection for abuse, but yeah, not so. So the interesting part is that they actually did not configure their tags securely. So the other tags in Vienna were just configured to a purely read-only. So no matter what key you have, you cannot rewrite the tags. But the stuff in Frankfurt and Darmstadt, now they actually have the tags set to read only. So they have a secret write key. So and if somebody could break that write key, you could instead of like putting your own labels on their tags, you could just write a small application for your mobile phone which knows the right key, and then you can just go through the whole city and just rewrite all the tags. And then of course you could cause a lot of trouble for the RMV. And of course I told them. I never heard anything about it, so I don't really care. Another thing is you have a lot of sectors in this MyFair cards, and if you don't need all of them right now, the others by default are just stay in manufacturer mode. And of course, if you place a tag in the public, you may like want to change the write key so nobody else messes with your tags. But they completely forgot that, so they have a bunch of sectors on the tags in the city where you can just store data or change the keys. So if you of course change the keys, they won't be able to like update the tags in a fashion where they like store more data in the future. So you could like if you change the keys, you could go to the whole city and change the keys, and then they will need to replace the physical tag if they want to do any update in the future. Of course, you should not do that because it will cost them a lot of money and pain. But so if you deploy tags in the public, make it in a way that you own the tags and not everybody else. I guess So now I just have some mixed stuff for the end. Some people suggested you could like do signatures like on your URL, so you instead of just having the plain URL on the tag, you could like sign the data and sign the URL so that your phone knows, okay, this is like a good URL. But again, they did not say, okay, what kind of PKI and who gets to like make good tags and who is like not able to make good tags. So very stupid idea. So I don't think we're going to see like really signed tags. Again, the RMV does this, but as I said, you could just copy the tag and copy the signature and everything will be okay. So since I was speaking about like replacing tags, good tags with bad tags, just something about that. If you have a small tag, you can always just like put some tinfoil over it and then put your own tag over the tinfoil, and then your tag will mostly be read instead of the other tag. If you have like really big tags, like in the Vienna thing where you have like your tag is like this size and your sticky tag is only like the size of a euro coin, your tag won't be read most of the time because That's the first tag, and put your tag over that. I take questions at the end, okay? Ah, okay, that's good. So I was just told in Vienna they have a big piece of plastic, but there's only a small tag behind that. So if you know the tag position, then of course you don't even need to zap that. So in the sticky tapes, yeah, in low quantities you pay like €1.20 per piece. So if you like buy, I guess 1,000, you pay much less. And then you can just like replace, stick your tag on other tags, or maybe replace complete tags. The best part, of course, if you like manage to like find tags which are not write protected, or where you can like break the key, you can just like hijack the actual tag of the service provider, and then there's no really evidence of any tampering, and you will probably be able to attack all the users of that service. So these basically are the paper tags, small round ones, a little bit bigger. Then some special tags which are enclosed in some plastics, so they're waterproof, so you can stick them outside. Down on the left, just some trials with tinfoil. So a small piece of tinfoil is enough to like break the antenna, and the bigger tag on the low side. So you always need a little bit space between two tags and the shielding, because if the shielding is too close to your own tag, you also break that antenna. So while I was playing with the phones, I actually noticed that the card emulation thing, every time you switch the mode of the card emulation, so the card emulation is where your phone actually is RFID card, so you can actually have a switch in your phone where you can say, I want my phone to be a tag, or I want to be asked before your phone turns into a tag. And every time you change that, the UID of your phone changes. So maybe you can do some funky stuff, because there are many like access systems that actually only use a UID of a MyFair tag. So maybe somebody can fiddle out to like manipulate the tag, the UID that your phone sends out in a way you can, in a deterministic way where you can actually define the UID. That would be really nice. Because otherwise there's no like API where you can say, okay, just phone, you are now this and this ID. Because then it would be really easy, because then you just like hold your phone up to somebody's wallet, get his access card, the ID of his access card, and program that into the phone. But that doesn't work right now. The other thing is, if you like put your business card like on a MyFair tag and then hand it to somebody else, and then somebody else like writes just a URL to the card and passes over to somebody else, the data of your business card will be still stored on the tag, because the phone will just like overwrite the small portion of data that is used by your new tag. So if you have stuff you don't want to like leak out, you should like clear the tag, because otherwise like all the data is always easily readable. Just some minor thing, because I saw people taking the small round RFID tags, the sticky tags, and gluing that on the backside of their business card, or other stuff they give like to customers, and they have like, I don't know, a business card or something on there. So if you pass it along and maybe change the content, you maybe still see, okay, you got like a business card for some, I don't know, adult entertainment place, and I don't know, just some small notes. So I thought, okay, we have this nice denial of service attacks, and many people don't like RFID systems because they're bad and insecure, and RFID is bad in general because, you can like track people. So I said, so maybe somebody really doesn't like the whole idea of NFC stuff, and how can you like stop people, especially now in the early startup phase, to from using the service. So you could just like make small tags which contain this really bad sequence that your phone doesn't like and reboot, and just place them on service tags. So if people use them all the time, they go there, their phone reboots, or the phone GUI reboots, and they try it again and again, and or the phone switches off. And I guess if you like hit a number of tags which like make your phone reboot, over time you will probably like stop to use that service, because yeah, it's really annoying. You might think your phone is broken, the service is broken. So if you're like into like the whole anti-RFID movement thing, you could have some fun with the NFC stuff too. Yeah, of course, I don't want to encourage anybody to do anything illegal, so maybe like even putting a sticker on something is already like vandalism, but who knows. Yeah, another thing, yeah, hopefully the last slide now, is the Nokia Bluetooth imaging thing, where you have, you can put a special data structure on an NFC tag, and then if you have a picture selected in your phone's picture gallery and touch the tag, the phone will ask you if you want to like send this currently selected picture to the device of which the Bluetooth address is stored in the tag. So they actually have like picture frames or printers, where you have a tag, and you can just, instead of like search for a Bluetooth device, you just touch the tag and transfer the picture. And I think I saw somebody in some forums like asking for like some copy shop where you can like directly print, like do picture printing. But like having this in a public place is like a really bad idea, because I just like put there my own tag there, and every time you print something, you first send the picture to my PC, and then my PC just prints it for you. So because there's no security or anything, there's an option where you can actually store a Bluetooth pin in there. But yeah, if I can replace the tag or put another tag there, then this is just a bad idea. So maybe like for your home picture frames, this is nice, but yeah, you shouldn't really try to do that in a public place. Yeah. So this is the last slide before the conclusions. The phone does not, all the Nokia phones don't only like support the standard NDEF stuff. You actually have a complete RFID reader, so you can actually also send APDUs to like smart cards. And yeah, so if you're really into RFID hacking and don't want to carry around your laptop anymore, you can like port all your nice RFID hacking tools to the J2ME stuff for the phone, and have a lot of fun there. Actually, one guy from the Netherlands who I talked to in October about this, he actually just wrote a RFID passport cloning tool for the mobile phone. So if if you can just punch in the machine readable zone into your phone and read the RFID passport, and then just write it out to another smart card. Yeah. So yeah, it is a lot less obvious than carrying around a laptop. So if you're really into RFID hacking, consider buying a phone. I think it's like 200 euros or something, so it's not that expensive, and yeah, you will have a nice portable toy to play with. Yeah, so yeah, some conclusions. So yeah, the early NFC phones seem to be very seem to have very trivial security leaks. Can have a lot of fun with it. Do some phishing, malware, write a worm, do some denial of service, and so on. Passive tags are bad. Maybe if you could like build like tamper-proof tags, but that's just like moving the problem. Yeah, so I hopefully have provided enough like basis for like further research. Hopefully many more people will start playing with the NFC stuff. Yeah, and if you're actually using NFC stuff, you really should like watch out and check the content of tags, and maybe look for stickers or anything, because maybe somebody is just trying to rip you off. yeah, some URLs where you can find tags and images and photos of tags. Yeah. So of course I want to analyze more phones. So if anybody has a non-Nokia NFC phone and yeah, would give it to me for like half an hour, so I can do some basic tests, this would be very nice. I would definitely buy you a beer. Also not for the Motorola phones because I had one in my hands and it doesn't work. Also very welcome are tips for new services around in Europe. So if somebody knows about a service that is not in testing, so it must be like in public use because testing stuff is boring but so if there are more services around here in Europe, I would like to hear about them. Maybe you can tell me now or just write me an email if somebody knows. And that's it. I hope you enjoyed. How much time is there left? Since we have no time, but no time officially. Okay.
Hello. One question.
Yeah. Question.
When you write midlets who access the NFC function, you have to sign them, or
no, you don't.
How did you circumvent it?
No, you don't need signing.
I have a Nokia 6131 NFC and I tried to install non-signed midlets and it didn't work.
For me, this one?
Yes, this one.
No, I just got a normal phone and you can just install any non-signed application and it works. And I don't know of anybody who has problems. You normally only need signing if you want to access the internal smart card.
Well, I tried to use the card emulation.
Yeah, for that you need signing.
Ah, okay.
Only, yeah. But I don't use card emulation. Ja. Ja, nicht hier.